We hear all the time about AI understanding language, but how does it actually work? Today, we're going to pull back the curtain on the core idea that pretty much changed everything, the attention mechanism. So, we're going to break this down into 5 key parts, and we'll start with an idea that's actually super familiar to all of us. Okay, so first up, what even is attention? Well, you might be surprised to hear the concept in AI is actually borrowed directly from how our own brains work. Yeah, just think about it. Imagine you're looking at a super cluttered desk. How do you decide what to focus on? Your brain just kind of knows what's important, right? This is a great way to visualize it. On the left, you've got what's called non-volitional attention. That bright red cup just screams for your focus. You don't even have to try. But on the right, that's volitional attention. You're deliberately looking for that book. Keep those two ideas in your back pocket. They're going to be super important in a minute. Okay, so how does a red cup on a desk relate to AI? Well, to really get why attention was such a game changer, we first have to talk about the huge problem it solved, the AI memory problem. For you and me, it's totally obvious that it refers to the animal. But how on earth is an AI supposed to know that it isn't talking about the street? The street can't be tired. See, the early AI models, these things called recurrent neural networks, or RNNs, had a major flaw. They process language in a straight line, one word after another. The problem, by the time the model got all the way to the word it, that crucial context of animal from way back at the start of the sentence, it could be totally diluted or even completely forgotten. This was a massive roadblock. So, how did we fix this? The solution is this really elegant idea called self-attention. And it all works because of 3 key components: queries, keys, and values. Remember those 3. Basically, instead of that fading linear memory, self-attention gives every single word a direct line to every other word in the sentence. It can look at the whole thing at once. Yeah, I love this analogy. You can really think of it like a contextual blender. It's taking the word it's looking at and then blending in the meanings of all the most relevant words around it. And what comes out is a brand new, super context-rich version of that word. So how does that blender actually work? Well, for every single word in a sentence, the model creates 3 little packets of information: a query, a key, and a value. The query from one word basically asks a question. It then goes around and compares itself to the keys of all the other words to find the best match. And that match creates a score, which tells the model how much of that other word's value, its meaning, it should blend into the final result. It's like a little negotiation happening for every word. And boom, here's where it all connects back to our human brain. That query is just like our volitional attention. Deliberately searching for the book. It's actively scanning all the keys, all the other objects on the desk to find the best match and decide which value or piece of information is the most important one to focus on. It's the same principle. So let's take our sentence. The query for the word it is basically asking, hey, I'm a pronoun. Who in this sentence can actually be tired? The key for animal pipes up and says, I'm a noun, I can be tired. But the key for street, not so much. That creates a really high attention score between it and animal, and the AI knows where to focus. Okay, but let's be real. Language is way more complex than just one relationship. A single connection isn't always going to be enough to get the full picture. And that's where things get really cool. This is where multi-head attention comes in. The model doesn't just do this whole process once. It's like having a whole team of specialists, all analyzing the sentence at the same time. So in our example, one attention head might be laser-focused on figuring out what it refers to, the animal. But at the same time, another head might be looking at the why was too tired. This lets the model build this incredibly rich, multi-layered understanding. You could have one head tracking grammar, another tracking cause and effect, all at once. And this is a peek under the hood at how it works. The model actually learns a completely separate set of queries, keys, and values for each one of these heads. That allows them to specialize in finding different kinds of patterns. Then, at the end, the outputs from all these different specialists are just combined or concatenated to create this really rich, complete understanding of the sentence. So, why was this such a massive deal? I mean, it sounds kind of clever, but this seemingly simple idea of multi-head attention completely, and I mean completely, revolutionized the world of AI. The biggest thing was this. Unlike those old, slow, step-by-step RNNs, attention can be calculated for every word at the exact same time. All those connections are figured out in parallel. And that Right there was the key that unlocked the incredible power of modern GPUs for training these AIs on just unbelievable amounts of text. The impact was just enormous. Suddenly, trading got way faster. It finally solved that core memory problem, connecting a word at the beginning of a document to one at the end. And this efficiency is what allowed models to scale up to the mind-boggling sizes we see today. This is the bedrock of pretty much every modern language AI you've heard of. So, in the end, this elegant little mechanism for understanding relationships isn't just a trick, it's the engine driving modern generative AI. And now that we're seeing it apply to way more than just text, like images and protein folding and computer code, it really leaves us with a fascinating question for the future, doesn't it?